Morning. In this video, we are going to study about GIS. So what is GIS? What is the importance of GIS? What are the components of GIS? These are the topics that we are going to discuss in this video. So what is GIS? GIS stands for Geographic Information System. And geographic information system can be viewed as a combination of the geographic data and the software tools. And these software tools are used to manage, analyze and visualize the data. So geographic information system has got two components in it. The first one is the data part, and then we have got the software tools. So together the data and the software tools combinedly form the geographic information system. So this geographic information system is very useful for us because if you want to make maps, if you want to analyze the components of geographic space, or we want to find answers, this is very useful. So basically we use geographic information system to understand or to give answers to certain questions. We are here to answer certain questions. Okay, so the questions are related to we use geographic information system to give answers to certain questions that are related to some particular things like location. So location is about where is the nearest petrol pump or like questions. Okay, that is related to location. Where is the next nearest restaurant, or where is the nearest bookstore? Such questions can be asked, that is related to location. And then the second one is related to patterns. Okay, patterns means like questions like, okay, where is the highest concentration of students live in an area, or where is the highest concentration of shopping malls or shopping shops in an area. Such questions that are related to pattern, they can be answered. Then there are questions that are related to trends or trends like where is the off city new supermarkets are found. So say that is a particular area is having new concentration of new schools are emerging in a particular area. So that is a trend, right? So we can analyze that trend and say we can start a new bookstore there or something like that. So these are related to trends. Okay. Then there is things that are related to conditions. Okay. Conditions means that something like a holiday stay that is actually within 1 kilometer from beach. So that is a condition that you're giving, right? I want to get a holiday stay, or I want to get a hotel that is actually within 1 kilometer from beach. Okay, so that is a condition. So such conditions can be answered. Then we can actually find answers for the implications. So for example, you are going to find a house. You have found a house, and you want to answer, if I move to this house, how far will I be from my office, or from the coffee shops, or from the petrol pump, or from the hospitals? Such questions can also be answered. That is, implications means that is actually the outcomes of the possible outcomes of you're going to take an action and the possible outcomes of it. So that is what we call as implications. So geographical information system actually used to find answers about things like location, patterns, trends, conditions and implications. Okay, this is what we use geographical information system for. And geographical information system, we can actually think about a few applications of GIS. So it includes something like searching for sites. So like searching for sites. What do you mean by searching for sites? Suppose you want to build a new mining center. Okay, you want to set up a new mine. Okay, then you have to analyze a few things like the environment impact of it, or the conditions required for mining, the availability of say the workers. You want workers available there, and then it should not be something very close to the city. It should be in a remote area. So such conditions need to be satisfied when you search for a particular site. So GIS has got a lot of importance here. So how you use GIS to find this? First, this we can describe the whole procedure using flowchart. So first, what we are going to do is that we are going to identify relevant siting factors. We are going to identify the relevant siting factors. Then we are going to collect appropriate data and we are going to digitize them. Okay, and then we are going to identify the siting criteria. Okay, and we are going to map them. Okay, then what we are going to do is that we are going to overlay the conditions. Overlaying means we are actually having different conditions. Say you have the social conditions like the availability of workers. Then you have the geography conditions like soil structure, the availability of minerals and everything. Then you have got some other criteria like say the forest criteria, the environment criteria. So you are actually combining these criteria and that is called as overlay. Okay. Now after overlaying, we are going to examine the result. We are going to examine, is this okay? If this is okay, we are going to produce the output. We are going to give the output. If it is not okay, then we are going to ask another question. Not okay. We are going to ask another question. Do you want more criteria? More criteria? If there is a requirement for more criteria, say yes, then we are going to then you are going to identify more criteria. Yes. And if you don't want more criteria, then what you're going to do is that, okay, we are again identifying siting criteria. You're going to again identify siting criteria. So I will tell this once again. So first thing, what you have to do is that you have to identify the relevant siting factors. You're going to identify the relevant siting factors. Okay. Next, what we are going to do is that we are going to collect appropriate data. We are going to collect appropriate data and we are going to digitize them. Okay. Then we are going to identify the new siting criteria. Okay. Siting criteria and we are mapping it. Then we are doing a map overlay, and if the output is okay, we are giving the output. If it is not okay, we are looking for, is there a requirement for more criteria? If there is, then we go straight to identify more criteria and we'll execute the loop once again. Else, if you don't want more criteria, then we'll go and identify the siting criteria again and we'll map it again. Okay, so this is how you find, how you search for sites. This is how you find the sites. Okay. For example, how this was done is like there was a NIREX. There was a NIREX, that is what was used to for once it was used for nuclear waste management. It was used as NIREX. NIREX was used for nuclear waste management. So you must have understood how important GIS is. See, you are identifying something like a nuclear waste management and you have multiple conditions to identify. Like if you are disposing nuclear waste, it should not be an environment sensitive area, it should not be near a large population, it should be remote, and it should have availability of water, and everything needs to be there. So this is done through GIS. So you must have understood how important geographic information system is. Next is we are going to evaluate land use and planning. This is the second kind of application. Evaluating land use and planning. So you're going to evaluate the land use, like the forest area, forest land use, and we are going to plan things. So like we are going to analyze like what is the long-term consequences. We are going to analyze the long-term consequences. So, let's say you are going to start a recreational activity. You are going to start an adventure park in a remote area, say in a forest. Now you have to understand what can be the long-term impacts of this. Say in a forest area, there is actually lot of people will be coming if you start an adventure park or something like that there. Then what will happen? There will be waste management issues. There will be pollution issues. There can be disturbances for the animals there. All such issues are there. So you have to understand the long-term consequences of it. Then we have to analyze the kind of damage that can occur. That may occur. Okay. Then what we have to do is we have to understand about the problem solving methods. Like you have to rehabilitate some of the animals or something like that. Okay. Then how it should be implemented. How to implement. Okay, so while we use in evaluating land use and planning, we have to identify the long-term consequences, the damage that may occur, and the problem-solving mechanisms, and how to implement the particular thing. So this is done by evaluation and land use planning. This can be done using GIS. So this is a major application of GIS. So how we cite areas in GIS? We can use maps. Maps like we can use paper maps, contour maps, field maps, and we can also use remote sensing. These methods can be used to cite areas for GIS. Okay. So this is actually another application of GIS. There can be several other applications like you can finding new places, or finding home, identifying criteria. All these things can also be done. So these are all the applications of GIS. So you must have understood that GIS is very important and there is a lot of applications that can be used in GIS. Now we are going to study about the components of GIS. What are the components of GIS? See, GIS has got mainly 5 components. Okay, the first thing is the computer system. Then we have got the softwares. Then there is the spatial data. Then there is data management procedure. And then there will be people and GIS, or people to operate GIS. So these are the components of GIS. The first one is the computer system. The computer system. Okay. So a GIS can actually be viewed as a software package, and the components are the various tools that we use to enter. Okay. So the computer system and software, or the computer system is actually the machine that we used to run the GIS. Okay. We can actually run GIS in a wide range or a wide spectrum of computers. That can be from a portable smartphone to your supercomputers. So that is what GIS. Actually, GIS can run in a whole spectrum of computers. And let's say the smartphones, they are used by a single user, while supercomputers are used by multiple users. Okay. And we can program them in a variety of computer languages. Mainly we use languages like Python and Java, but we can also use other languages as well. And then we can have the processor, or we have the computer system. The computer system that we use must satisfy a certain things, the following conditions. These are actually essential for the effective GIS operation. So the conditions include there should be a processor with sufficient power. So we want, see, GIS has got a lot of data in it and you have to process all this data. For that you need a processor with a sufficient power, and there should be sufficient memory. Like as I've told, there is large amount of data that is need to be stored. There should be sufficient memory. Then there should be a good quality graphics screen. And then you should need data input and output devices. Okay, so there should be a processor with appropriate power, there should be sufficient memory, and there should be graphic screen, and there should be data input and output devices like digitizers, scanners, keyboard, printers, then plotters, and all these things are actually required. Okay. Then we should also have, then we have the software things. Yeah, we want the software. Okay, so software, we have to, what we use software is for, actually for, we use it to input data, to analyze data, to manage data, to process data. All this we need a software. Okay. And we also need it for the graphical user interface or user interface. For this we have graphical user interface or command prompt interface. Prompt interface. So in graphical user interface you have something like a point and click mechanism where there is a menu and you can click on that and you get the action done. But in the prompt you have got queries. You can use queries to do the actions. So that is the software that we use. Softwares are used to store, to manage, input and transform and analyze and output data. So there is the two main things, that is graphical user interface or prompt. For user interface we use command prompt or graphical user interface. Then we have got this third major important component of GIS, that is the spatial data. What is spatial data? Spatial data is actually relative geographical information about Earth. It is the relative geographical information about Earth and its features. So geographical spatial data actually consists of the position, we have the connections, and we have non-spatial entities. So the position is actually, it can be done in latitudes and longitudes, that we use for geographical referencing. That is, that we have to find the position of a particular thing, the location of a particular thing. For that we use latitudes and longitudes. Then connections we use such as like roads or waterways. Then we have like railways. All these connections, these are continuous connections or connecting the geographical locations. We need the connections. That is why we need the connections. Then there is the non-spatial entities. So that is like the things like temperature or rainfall. That may always change, or the temporal things that are actually changing, and they are not actually completely dependent upon the geographical space. It includes like temperature, raining and all these things, rainfall and all these things. And this spatial data can be represented in two ways. The first one being the thematic representation. There is two ways to represent this. First is using the thematic representation or object oriented representation. In thematic representation, the representation is based on a particular theme, like say the soil. Soil is the theme. We are talking about the soil only. The types of soil, whether it's laterite or alluvial or red soil or black soil. Talking about that, that is the thematic representation. The object-oriented representation, you are giving more importance to the objects. The objects include objects like places or entities, and all these things are called the object-oriented representation. Okay, so how we represent data in spatial data in GIS. Actually, we have to represent the objects in a simplified way. We need to simplify things. We need it to be simplified things. So for that, we actually concise entity to know specific representational forms. Like we use 3 forms: points, lines, and areas. Points are actually used to point out small things like schools or cafes or things like that. Lines we used to represent continuous things like road or waterways or railways, all these things. And areas we are actually used to implicate a large area like a park or a forest or such things. We use what? The areas. So we have 2 models used to represent spatial data. It is called the raster model and vector model. The raster model and vector model. The raster model is actually also called as grid or grid model. It is also called grid model. Okay, we'll talk about this raster and vector model in detail in the upcoming videos. But you see, raster model, we actually use raster model to represent isolated things. While we use the vector model for representing the continuous things. Okay. Then we have the data management and analysis. So this includes things like data input, storage, management, transformation, and analysis. So data input, we are actually inputting data in data input, and data management, in data storage, we are storing data in a digital format. So in data input, we are actually inputting data in such a way that it is understandable to the computer, so that we have got data in various formats, like in the form of maps or pictures or digital format itself or tables. So we are inputting data in such a way that it is understandable to the computer. So this is called as digitizing. And then we are storing the data in a digital format. And then we have got management. Management is actually a collective term used for storing, organizing, and retrieving data. And this is most probably done using database management systems or DBMS. Okay, then we use transform. In transform, we are actually converting data, or we are transforming spatial data from one entity type to another entity type. Okay, that is, we are actually transforming it into points, lines, and areas and all these things. So that is what we use in transform. Then analysis. In analysis, we are actually analyzing the data. Okay, this analysis procedure can be of 3 types. The one is used for storage and retrieval. Then we have queries for analyzing data, or queries that we used to look at certain patterns. Then we have the modeling procedures. So analysis can be done either for storage and retrieval, or by queries, or by modeling techniques. Okay. So this is actually data management and analysis. Then there is something called data output. So data output, what we are doing is that we are actually presenting the output or presenting the data in a way that is understandable by the audience. Next, and then finally we have something like we have the people and GIS. So we all build GIS application for the users, right? So GIS applications are very user specific or application oriented. Okay, GIS, all GIS systems are user oriented or application oriented. So as a result, we have to, whatever we make, we should always consider about the people. So that is, the people is actually the most important part of GIS. So as I've told you, we are actually discussing about the components of GIS. The components include a computer system, the softwares, spatial data, data management process, and people and the GIS. Okay. So in the computer system, we need a processor of sufficient power, then we need sufficient memory and graphics key, data input and output techniques or things, output hardwares. Then we have software. Software we use for presenting and inputting and analyzing data. Then we studied about user interfaces. There is graphical user interface or there is bash interface, or that is we use by command prompt. Okay. Then we studied about spatial data. Spatial data includes the position, connections and non-spatial entities. Okay. It can be represented in two ways, thematic way or the object-oriented representation. And we studied about data management and analysis. In that we have data input, storage, management, transformation, analysis and